Hello and welcome to another, PlayBASIC blog. The date's it's about the 9th of August 2017. So the last few weeks we've been tucked away doing a few different things. We've got our 165 revision B out there and been actually using it a fair bit myself. Found a few problems. The debugger's got some problems, that's for sure. So there's problems with the debugger. Like most revisions, the next revision starts the day after its release. So I'm actually working on a revision C of 165, and that's really just to clean up those remaining problems and hopefully get the command set, the internal command set, using the best external caller. At the moment, we've got so the runtime runs through. If you type a command, let's say I don't know, dot, give it a coordinate, right? Now, what actually happens when this thing is being executed is the VM generates a function call of this command, and the problem with the way it works at the moment is that it's too generalized. It needs to be more tied down. What I mean by that is there's actually a lot of overhead in just calling a command from the library, because that's what it actually has to do. It has to work out what command set this thing is, because the VM stores it. It stores it like, let's say that the dot command is in command set 15, right? So it kind of makes there's an instruction to, it's like a call command instruction, let's say, and it's let's say dot's in command set 15, and dot might be command 5 out of that, and then we have the parameters at the end. It's a very crude, sort of overview of what's happening, but that's basically how they work. Now, this call command is extremely generalized. It can handle calling commands, handle returns, all kinds of stuff that dot doesn't need. What we did with some of the other features, like when you link a DLL, if you have a DLL here, I don't know, some Windows DLL, for example, and has a function in there that you want to use. You go some function, list its parameters, A, B, and C, give it the alias, and then tell it the actual name of this function inside the DLL. And they can be mangled and all kinds of stuff. It might, depends on how that DLL is compiled as to what this name could be. But hopefully it's, something simple. Not really my point, actually. Okay, so when in the new version of the runtime, this function here is now, once it's defined, it is a direct call to this function, and it works this out up front. So it no longer has to do any sort of looking up where this function is in memory. It's pre-computed before the runtime starts, finds the address, patches the address in, and then when you call it, it's really just the leanest bit of code to do this. You've got to copy the parameters onto the stack to call this stuff, and clean up the stack at the end of the calls. But it's I'd say it's probably faster to call most of these, like a linked DLL, than it is to call some of the command set stuff, because these have kind of optimized decision based in there. So when the compiler sees certain patterns, it goes, oh well, you can use a common pattern and you can use a more complex pattern that handles general cases. Yeah, because if you have some function defined that's got like 15 parameters, I can't really optimize that out inside the runtime, so I would just use a some function, some big, jeez. Hopefully you sort of get the point I'm trying to make, is that the runtime would have to have a generalized version to call this pattern here. Yeah, but for some of these kind of smaller, what I mean by smaller is functions that have simple parameters. So you're passing something an integer or float. The runtime doesn't have to do any work to it to get that thing onto the stack. When you pass some of the more complicated structures across, it has to do a lot of work to get that into a state that can be passed to some external function and return. But in general, these simple functions are now faster than the internal commands, and that's a bit of a frustrating situation. It all comes back to how the command sets are defined internally. You've got this, like that's the dot command. So of course internally somewhere there's an array that has there's a command called, let's just say it's a data statement. There's a command called dot down keyboard, and then it might have it has I don't know, has two parameters, and the parameters are integer. That might be how you're thinking it works, but it doesn't work like that. Because we have a kind of ambiguous, we try to get rid of some of the forced casting early on. So we actually have these kind of certain command can actually have a parameter be, we can force an integer requirement, we can force a float requirement, or we can do a combined thing. So we can tell it that we just want it to be numeric. So that will allow integers or floats passed in. Which is kind of a cool idea back in the day. It made making the tables easier. But now we don't want this. This is one of the reasons why core command is kind of slower than it need be, because it's kind of going, okay, if you use a command that's got these kind of ambiguous parameters in here, it has to make comparisons to check what you're passing in against what the command actually requires. Because that, sure enough, internally there's a dot command in there, dot function, to draw a dot to the surface, and it has, in this case, that the x and y coordinate are integers. So if you're passing floats in, those floats need to be converted to integer to call that function. What fun and games! Stuff that no one, you shouldn't have to think about this stuff. If we didn't have these numeric types, you would actually, a lot of programs would just chuck. You'd be constantly going. Let's say if dot actually, let's say if dot was defined like this. We've got two parameters, and they are float and float. Well, this command here, this thing here, I'll get rid of that junk. Hopefully the demonstrations, the points been made. If I wrote this command here, the compiler would trip this up and say, nah, these are a mismatch. That's an integer, we want a float. So you'd have to actually cast it. Now, obviously those with a keen eye will realise that's just silly. I could just put a 0 on the end, and that would satisfy it. But what you're doing there is you're actually adding this. So what's being generated is, you've got this call command. I'll just make a shortcut. We're calling the dot command, and we've got this. We'll call it temp int 1, temp int 2. So this bit of code here is actually generating this. So we're going temp int float 100. Oh, sorry. That's just should be temp float. If I was going to be making these floats, for example, float 100. Sorry, to satisfy its criteria, as in the parameters have to be floats. So that's kind of overhead for nowhere. That's why we have this kind of generalized numeric parameters. And it's not just numeric parameters, there's actually another one, a couple of these ones sprinkled throughout the command sets that let a command accept integers, floats, and strings. There's another one that lets that command accept ints, floats, strings, pointers, almost anything. It just assumes that when the command is called, it's going to know what to do with whatever you've passed it. And that was okay back in the day, but we don't want to do that stuff anymore. We want this thing to be lean and mean. That means getting rid of some of this old crap. Unfortunately, I'm still silly idiot who has to do this stuff. Alright, so our point is that we've got over 1,000 commands defined that often have these kind of generic numeric sort of fields in them, and it just kind of the compiler accepts either one as lets those through, and when you call the command, it looks at the parameters and goes, okay, I need to recast you, I need to recast that. So there's work done inside the command. That was done really because the runtime itself would solve the parameter patterns. So it kind of seemed good at the time, but things change. Okay, so that's the problem we're trying to solve. I'm trying to think of an easy way of solving. I don't really want to sit there and go through every command and have to go through all that jargon again. What I was thinking about was I could probably introduce, rather than just having this really generic call command process, let me just get rid of that junk there. So just imagine there's a numeric. I think in terms of dot, for example, I think actually fast dot is defined to only accept integer parameters for that very reason, to try and get rid of some of the overhead when calling a dot, because dots are very granular. They're very, you're going to be doing that thing a lot. When you start using dots to fill in the surface, you've got a lot of overhead to lift. One of the ideas was that I could possibly tag certain instructions, tag these commands as having a different type of parameter definitions over here. Might be able to do something like, I can still have this like numeric, let the compiler accept those things, but it might be numeric int. So which won't represent, you can have, it'll accept any numeric value at this parameter, but the output of this has to be integer. So in the caller itself, it's not actually making comparisons. It can work out a pattern to call this that has conversions in it up front, which is one of the problems of this kind of really generic, this generalized approach. And that's how the new function patterns work, and the new, as I said before, the external function calling stuff works as well. It looks at what you supplied it, looks at exactly what it needs, and it converts things that it needs, and we get rid of pretty much half of the work that was being done up front. We can do a lot of this stuff at compile time. And for calls that are don't need any conversion at all, they can just be passed straight through, which is obviously a big gain in terms of performance. So that's what we're talking about. That's what I'm sort of looking at. I've been doing a bit of clean-up work with it as well, with 165 in general. I haven't jumped in and implemented one of these approaches yet, because I'm sort of terrified by what's going to happen. If I jump into an idea and then discover, oh, I'm going to have to rewrite a whole bunch of stuff, I just don't want to do it, to be honest. I guess to make another example, the command set has this generalized numeric approach to numeric values. So ints and floats are interchangeable, regardless of what the actual thing you're calling wants. The same as user functions. If you have my add values or something, you have an integer, 3 integers or something. Oh, that's our result. So result is just this plus that. Now, hopefully you wouldn't do things like make functions that are one line of code, but people do it. Anyway, when I call this function, if these parameters here are integers, the call mechanism doesn't do any conversions to the parameters it's passing. If they're not integers though, you would normally have to recast those things. If I was passing in floats, most languages would trip you up there and say, hey, you can't do that. They're different data types. What do you want me to explicitly do? So you'd have to do something like, wrap ints around them. That's one of those things that we just thought was so clumsy up front. We wanted it to be be a little bit liberal. There's exceptions to those rules though. Like you can't, if I define my pointer as pointer, for example, I can't then just try and jam that here into this parameter, because I'm comparing a pointer to an integer. They're not of the same type. It doesn't know what to do with them, even though they are just integer values at the end of the day. There's nothing all that special about it. But this is classified as that pointer type. This is classified as an integer type, and it won't let you do that stuff. So in that case there, you would have to wrap that int around it to treat it like it's just an integer, even though it is just an integer. Pretty boring stuff, eh? So just what 165C is going to be all about is this kind of mundane, head-banging, boring, probably bug-ridden kind of translation. And I want to have every single command externalized. And when that happens, we can do anything. It's frustrating to be at that point, almost at that point now, and be looking down at the code base going, oh man, I've got to make a whole bunch of other changes to it. I just don't want to do it. Right. So that the issue is, we want to clean up the internal command set defs and caller in VM. What we should end up with is not only better performance, actually, we end up with something that is easier to convert to machine language. All the work's been done. You just the translator doesn't have to do anything. It just goes, well, okay, I see this instruction, it has set up like this, so I just dump the code out like that, and bang, we move on. So the other thing that was kind of interesting is, like, it's been a common topic of conversation for a while now, is the translation. Is the translate to, well, really it's JavaScript, or you can call it web, whatever you want. Now, I've talked about it a while ago, and you might have seen the early translated, where I'd worked out how to get traditional BASIC to run, to actually be translated to JavaScript and run, and you're still allowed to do things like goto, gosub, and a whole bunch of other basic isms which you can't do in JavaScript. In fact, most of the structure you're probably comfortable with, you can't really do in the browser setting. You don't get a pretty result, but it really mangles up your code to high heaven. So there's a time there where I thought, well, if I think there's a survey on the board there at some point where I'm asking people, can you program without goto? And everyone goes, yeah, no worries, not a problem. Well, that's all well and good, but when you look back through all the old code, you just find bits and pieces where gotos or make life easier. You just, rather than refactor something, you found your condition, jump out of here and move on with life. It's one of those things where, do people have to change the way they write their code? And that's frustrating for people. And for me as well, I'd rather just write a bit of code, run through the translator and have it run, than do anything else. So that's all well and good, and then that problem was solved. I think it was about 4 years ago now, 3-4 years ago. It was on my way. I was cycling back from Frankston back to Melbourne on the big day out, and the whole way home I felt terribly ill. It was a very hot day, and was underprepared chronically, and so the whole way back I'm just cramping and just feeling sick. But on my mind is this solution. I'm just going, that's going to work. That actually, I can port this to anything. Very frustrating. The alternative was to do something like native client, which is kind of Google's baby, I guess. Native client is just you compile your application to native, and it runs in a kind of sandbox environment inside the browser. Of course, that's pretty problematic because they're only using x86, 64-bit. I think it was 64-bit. So at the time I thought, well, that's pretty cool, because if we can do PB to DLL, which we can even with the old versions, and we could build a version of that that dumps, dumps PB the native client. Stands to reason, doesn't it? You would need to move a lot more stuff internally to externally, though. Yeah, and it doesn't actually. It's not a solution really. So these days you've got, the your PB to JavaScript solution, which is perfectly doable. Most people use these days to do web versions of their products. They use C to Emscripten. They pass their C code through Emscripten, and you get out an absolute monstrosity at the very end. But you do get something that will run, warts and all. And I just don't want to do that. I could get the VM, pass that through the same process, but when you run it in the browser, you're actually running the interpreter in the browser to interpret your logic. To me, that's a terrible solution. Didn't like it then, don't like it now. So obviously, what we want to do is we want to convert from the new instruction set into JavaScript, but with WebAssembly at the moment, you've got to ask yourself, well, why even bother with JavaScript and just go full WebAssembly? And it's not that different to dropping 68,000 x86 code from here. The beauty of that is that it's a deliberately designed processor, sort of pretend processor environment that you can compile your code down to. The browser loads it up and jits it for your target and runs. So you're not dishing out pre-compiled slabs of x86 or ARM code, which is just clumsy. This way we can get rid of that. That's one thing I actually like about where the web's going. The rest of it I kind of hate, to be honest. But we could do that. So the hiatus has kind of become a reality, and was kind of bouncing around there 12 months ago. I thought, oh well, maybe it will be something, but now it could actually be a target. Yeah, hopefully it kind of gives you a bit of insight into those things. It just comes down to, I mean, how many people are actually bending over backwards for these translators? If no one's into it, I'm not going to waste my time doing it. I mean, it's actually not that difficult to do now. Probably should get around to updating PB to DLL for 165 generation anyway. Might actually wait until we've done all the cleanup command set stuff. And then once that's done, we should be able to just go, bang, here it is, here's the translator. Enjoy that. Alright, actually the other thing I wanted to talk about is a bit about their forums. Hopefully you've caught some of the new videos we've been making, and there's a bit of a thread up here in the forums. It's got a bunch of videos that I've been going back through and sort of making, which has been a pretty interesting sort of thing. Actually, a lot of stuff I'd forgotten, to be perfectly honest. A lot of stuff I'd forgotten. Some good stuff tucked away. Some kind of the methods used are a bit questionable here and there, but that's just what happens, you know. The videos are actually made on my other PC, and if you ever tried capturing a directory or a window, you'll probably have discovered that it doesn't work very well. I have to use two different separate applications that do it at once, and then you have to sync up the resulting. So I'm using one app to record the video and one app to record the sound. Actually, probably, yeah. For those who haven't actually played it, check out Never Dawn. Very good. I really enjoyed playing that game. I've actually forgotten all about it, to be honest. Tracy's prototype it's a blaster prototype. It's got lots of interesting effects in it, actually. I think the date on here is wrong, actually. The date in the code says it was from 2004, but when I looked looking for a thread before or after I posted that, it was like from 2006. So I think it was the example is actually based on one of the old platformer examples that came with PB. I think it's actually up here somewhere. You've got your videos of the OpenGL stuff, just particle effects from 2 years ago. You know, a long time ago. No one's used it. Street Fighter stuff from 10 years ago. Multi-camera stuff. Some of these didn't have audio, so I just put audio, you know, separate songs on them for Fox's sake, which is, you know, it's pretty good. That one was struggling to capture that one, to be honest. Yeah, definitely the capture works. Like, I don't really have a high-end PC. Even my desktop PC is it's pretty low spec, and it's kind of frustrating that you can't capture well, even in 2017. But anyway, so what I was hoping to do is get a lot of these old things up and on the PlayBASIC channel, of course, on YouTube, by the way. I don't know what other ones have been made. Oh, there's a few other ones up here, I guess were made for. Oh, it's the. Gee, when was that made? Seamus. Oh, there you go. 2003 that was made. It's pretty terrible. Some of these old ones I would love to go back through and do a work in progress, or sort of go over why decisions were made in a certain way and look at the code. And we made this in 2 weeks. The competition went for 3 months, and we didn't want to do it, and then got sort of talked into it, and we thought, we'll do a remake of Seamus, and it turned out no one knew what Seamus was. No, absolutely no one remembered the game. It's a bit of a shame. And our version's pretty terrible of it. But it was one of those things that was on our site and just had, you know, didn't have a representation. Didn't have any, didn't have any representation on the site, and a lot of these old things here were just sitting there and there's no videos, and I think they've all got videos now. Don't know. Can't remember. Anyway, so if you want more information on how to capture those things, I'll make something about what I used to do it. I think it's actually in the chat section up here. There you go. Free video capture software. For video, I use this. And for audio, what am I using? I can't think now. On my main system, it actually lets you can pick your internal mixer in the sound card, as a recording device, so it can record what other programs are actually playing. So in terms of capturing, that's brilliant. But on this PC and my other desktop, I can't do that. It doesn't have that hardware, so I got a feeling that might be kind of limited. Alright, ramble on enough. So I'll get back to updating stuff and get back to updating 165 and make some more videos and try and keep those things going through the system as I possibly can. And I'll leave it there. So thanks for dropping in, and I'll catch you some other time. Bye.